The three vertices of a parallelogram are provided to us. We need to determine its fourth vertex. So let us begin. So let us consider a parallelogram with vertices A, B, C and D. Now the three vertices are given, so we'll suppose that A has the coordinates A plus B, comma A minus B. B has the coordinates 2A plus B, comma 2A minus B. And C has the coordinates A minus B, comma A plus B. Our goal will be to determine the coordinates of the fourth vertex, that is the coordinates of D, and we're going to assume that that is x, comma y. Okay, so our goal will be to find out the coordinates of point D. Now how do we do that? We'll begin by joining the coordinates of point A and point C. That's going to give us the diagonal AC, and we'll also join B and D, which is going to give us the second diagonal. Now, what we can do, we will use a property that the diagonals of a parallelogram bisect each other. If they bisect each other, that means they are going to have a common intersection point E. Now, we can say here that the midpoint of the diagonal AC, that must be equals to the midpoint of diagonal BD. So first, let's obtain the midpoint of diagonal AC. To obtain the midpoint of diagonal AC, what we'll do, we'll sum up the x coordinates and divide it by 2. So A plus B added to A minus B, so that's going to give us 2A. And we're going to divide it by 2. And similarly, to find out the y coordinates, we'll add up the y coordinates of the endpoints A minus B and A plus B. So that's also going to give us 2A, and we're going to divide it by 2. So we have the coordinates A, comma A. Now that we have coordinates of the midpoint E, so we have A, comma A. Now we can say that the diagonal BD, it's also going to have the same midpoint E. Midpoint of diagonal BD. So that's going to be equals to, what we'll do, we'll sum up the x coordinates. We have 2A plus B plus x, 2A plus B plus x, and we're going to divide it by 2. This is going to be the x coordinate, and for the y coordinate, we're going to sum up the y coordinates of the endpoint. So we have 2A minus B added to y, and we're going to divide it by 2. We're going to use the condition that the diagonals of a parallelogram bisect each other such that their midpoints are going to be equal. So what we can do, we can take the midpoint of AC, where we obtain that its value is A, comma A, and equate it with the midpoint of BD. So we get 2A plus B plus x divided by 2. And the y coordinate, we have 2A minus B plus y divided by 2. Fine. Now we're going to equate the x coordinates, so we get 2A plus B plus x divided by 2. So that's going to be equals to A. Fine. So that gives us 2A plus B plus x, and this will be equals to 2A. So we can cancel out 2A from both sides, and solving for x, we get x equals to negative B. Similarly, we can equate 2A minus B plus y over 2 with A. So that's going to give us 2A minus B plus y equals to, so this is 2A as well. We have 2A. So here also we have 2A cancelling out. Solving for y, we get the y value as positive B. So that means the coordinate of the fourth vertex of the parallelogram, that's going to be negative B, comma positive